if you believe what you hear, if you believe what everybody is saying, enterprise Android is just about to happen. Okay, so you know the days when you went out and made $100,000 writing an iOS app, you know, an iOS game or something like that, are probably behind us. And what's ahead, though, is things like this. I mean, this is just a random sample of a random collection of stuff that I found just by querying for enterprise mobile. It seems that all sorts of people are predicting that that's just it's sort of inevitable. That's the way it's going. And I've always said that the big place for Android is not, or a huge place for Android is not so much your phone. I mean, that's nice and all. But the place that you're going to see Android all over the place is OEM devices. When the FedEx guy shows up at your door and you have to sign something, that's going to be an Android tablet. And when a waiter comes over to your table and wants to run a card through something, that's going to be an Android device. And they're going to be all over the place. All the quiet things, all the ones that you don't talk to so much, those are going to be Android devices. And Android in the enterprise is making people nervous. So there are all sorts of reasons. Just mobile stuff in business makes people nervous. There's the whole bring your own device problem. As I say here, let's not even talk about security. People are scared to death about security. Decentralizing the business. This one is huge, of course, is the load on IT. If you can bring your own device, then IT is going to have to at least either support it or figure out how to tell you that they're not supporting it or something like that, okay? So it's a big deal. I think as developers, though, we have an additional problem. I think that as the mobile crew meets the back-end service crew, there's going to be a clash. There's going to be a style issue, okay? Which I sort of try to express here with, you know, this guy who has a master's degree in science and our skateboard punk over there. The mobile looks at the world differently. The mobile developers have a different experience, even Java mobile developers, and even now that mobile has been tamed to the point that it is tamed in Android. How many of you had to work on J2ME? You know, I'm really sorry. I just totally apologize to you guys. I mean, that was awful, right? And there were worse things around. Okay? Android is fairly tame compared to that stuff. So here are some things that web service developers take for granted. An incredibly rich source of open source frameworks. Okay, we've got everybody, it seems to me that virtually everybody who's ever written a web service has written a web service framework, right? There are a million web service frameworks out there. There are great things like Spring and Hibernate. There's all this stuff sitting around that as a Java developer, your main job isn't to know a language or even the library that belongs to Java anymore. Your main job is to understand the environment of frameworks, what frameworks there are and how to use them. Nearly every web service developer takes for granted an RDBMS. And that's a big deal because it means that, for instance, there's such a thing as a global singleton. There's a way to lock, there's a way to say across all of the instances that power your web UI, there's a way to grab a single lock, okay? Because it's the database. That in the big things, the things Amazon and Twitter and Google and people like that, that's not necessarily the case. Okay, they've outgrown Oracle or something like that. But a lot of us still think in terms of it's possible to put a lock on that row in the table, and all of the instances, no matter how many there are, believe that that thing is locked. Unit testing. Okay. Unit testing is just part of developing now. It's just part of the deal. And this one is kind of fun. If you've got a rack-mounted server back in your somewhere, what you want is that thing running at 100% CPU all the time. That's what it means to be optimally used, right? God forbid, optimally used for my phone is that the CPU never runs. Okay, if the CPU never executed a cycle, it would be best, because the most expensive thing on there is the battery. Things mobile developers take for granted. So first of all, networks are unreliable. We're pretty much used to believing, a lot of us are pretty much used to believing that a network is just sort of an extension of your computer. Okay, the stuff on the network is just always there. Okay, and mobile developers know that's not the case. You can start to do something just as you go through a tunnel, and that's that. Furthermore, the OS is unreliable, and finally, the hardware is unreliable. Okay? Mobile developers work in an environment where you can't count on anything, where everything is about details. It's about this works this time on this device, that works that time on that device, right? There's actually some common ground, I believe. So for us Android developers, an activity is a servlet. It really is. It is exactly a servlet. It has the same life cycle. It has the same responsibilities. It's just a servlet. We can talk to each other about this. An activity fills that role. Developers on both sides have to deal with the life cycles of managed objects. Objects come and go. One of the biggest problems in Android, one of the things that's hardest for people to get used to, is that they don't have an application. They have an activity or a service or something like that, and that service can go away without much notification. Well, anybody who's dealt with J2EE is totally familiar with that. Okay, so that's something that we share. Concurrency is in your face in both environments, and testing is painful in both environments. Any place where you have a container, where you have to work in a container, testing is a pain. So what I'd like to do for the rest of this talk is I'd like to pick a couple of things that have appeared, that challenged me when I started doing this. I took the wrong path, right? And I ended up doubling back and doing it a different way, right? And maybe I can save you some time. There's a friend of mine once told me, and I don't know if this is a fact or not, that there's a sign on the wall of Carleton College, on the gates to Carleton College, that says, learn from the mistakes of others. You can't possibly live long enough to make them all yourself, right? For what it's worth. So what I'd like to do here is I'd like to pick these three things, and I'd like to do deep dives in just a couple of places in each of them, okay? I'm not going to present either an overview of any of them or detailed implementations of any of them. I'm going to pick and choose the things that I thought were either painful or interesting, okay? So if this seems like a hodgepodge, it's because it is. So my first suggestion is that you just get over it and embrace cursors. Okay, so if you come from web services, the first thing you're going to do is, and you hear that you have to deal with data, the first thing you're going to look for is some kind of ORM, some kind of object relational mapping software, Hibernate or something like that. Abatis, there are a bunch of them around. They exist for Android. My advice, pay no attention. Just use the cursor. So here are some reasons. Here's some reasons that I suggest this. First of all, it's the simplest thing to do. Okay? A cursor is already there. The cursor is already sitting there. It's already pretty amazing. It works across processes and things like that. Just use it. The second argument is the cursor loader. The cursor loader is a fantastic way to get data into your application quickly and easily, okay? It works. You don't have to worry about managing it and stuff like that. It just works. A cursor loader will return you a cursor, okay? It won't return you some, ORM tool. It will return you a cursor. Use it. A list view puts the cursor right up against the glass, okay? You hand a list view, you hand its adapter, a cursor adapter, a simple cursor adapter, you hand it the cursor. It's right up at the glass. That is to say that all the way from the back end, all the way from the database, clear to the glass, Android is already thinking in terms of cursors. Content observers. Content observers make life really simple when you want to get updates. When you use the second technique I'll describe in a minute, especially. When the data set underneath a cursor updates, you can get notifications really, really simply using a content observer on a cursor. And finally, the cursor works across process boundaries. Exactly the same code, the code that you write in your activity to load information from a database works whether that database is part of your process or part of somebody else's. The big arguments against a cursor are the mutable row pointer, okay? It's a pain in the neck that somebody can move the pointer around on you. If you ever want to see really, really interesting bugs, in your view binder, which is part of a list view, in the view binder, move the row pointer, okay? You have access to the cursor, just move the row pointer. Boy, is that awful, okay? So you need some sort of protocol for managing that row pointer. The second problem with cursors is that they're not thread safe, okay? So if you're going to pass them around across threads, you need to do something. I have a suggestion here. This is the first of my deep dives. I have a suggestion. I suggest that if you need, in those circumstances where you are not passing the cursor directly to a list view and simply viewing it, which is mostly what you will probably do, in those cases where you need to do some calculation or you need to do computation on stuff that's in the cursor, that you wrap the cursor with a really simple wrapper that provides you with getter semantics and restricts access to the row pointer in the cursor. So I'm not saying that this is a solution, this is a general solution, okay? In particular, it doesn't handle n-to-many relationships, okay? It doesn't handle the case where an ORM would return a list, okay? It doesn't do that. And it's still not thread safe, but it is kind of neat. So here's an example. This is how you would use this tool to wrap a cursor. The constructor takes as arguments, it takes the cursor that you're going to wrap as its argument. To the superconstructor, it passes that cursor and a list of the names of columns that cursor might contain. In this particular case, what you see here is these are all of the column names from the contract. Okay? So the content provider publishes a contract. That contract has the names of a bunch of columns in it. You simply put all those columns here in the constructor, and then you write your getters. And the getters simply get back the values from those columns. In use, this is unnecessarily sparse, I think. But the point is that if the container, if the top layer holds access to the cursor, and it's the only one that fiddles with the cursor pointer, and you use the wrapper to manage the cursor everywhere else, most things that you do are safe. Okay, it's still not thread safe, but most of the things that will happen inside there are safe because nobody can get at that row pointer. Nobody is actually looking at the cursor. And they're using standard getter semantics to get stuff out. And here's the base class. All it does is it builds a map. So it walks through the cursor. So it has to do this at runtime. Each cursor contains different things and may contain the columns in different orders and so on. So it has to take the cursor, walk through it, and for each of the arguments that you passed here, it has to see if that column is in the cursor, and then it just provides a way to ask for the index that corresponds to a column name. You probably have to do that anyway. This doesn't cost anything. You have to compute that column index. You have to compute the column index for the cursor name anyway. So this may be excessive in that it computes more column name indices than you actually need, but it's 2 or 3. The only real expense is getting the thing out of the map. I suggest it. I suggest it. So I've just shown one way to sort of to make cursor access a little prettier. And I suggest that the point of one of the reasons for DAOs and so on is to abstract cursors away. Okay, in your web services, people wrote programs and they want to abstract the idea that you're dealing with a SQL database. They want to abstract it away. So they decided, the direction that they took was say, okay, we'll hide the cursors. Cursors are inherently database objects. Let's hide them. My suggestion is that you take a different tack on this and you think of a cursor as a relation. Okay? Relations are well defined, they're well understood, they're easy to explain, and they're a good abstraction for data. A cursor is a relation. Use it as your abstraction. Just go ahead and use it. And what's next? Well, next is that networks are data. If you're going to do enterprise Android, you really owe it to yourself to look at this 2010 talk. I think his name is Dobjanschi. It's a brilliant talk, although it might take 2 or 3 times through it to understand it. And what I hope to do in the next 15 minutes is help out with that, okay? So when you go back and look at his talk, it might be a little bit easier to understand after listening to this. If there's a key to this, to what I'm saying here today, it is this, okay? This is the heart of enterprise Android. This is the thing you have to do right. So the point here is that it's a figure 8, is that the UI never, ever, ever talks to the network. The UI only talks to a local cache, which is a combination of a service and a content provider. And then this thing is synced up with the network. Here's what outbound processing looks like. So the user changes state. For example, consider contacts or something, contacts that are synced to the network. Right? So the user changes somebody's phone number. Okay? I'm trying not to say async task here because I'm going to be all over them in a minute. But the state changes. So what happens next? So the activity is the thing that's responsible. It's the controller. It handles the state change. And what does it do? It calls the service helper. Calls down to the service helper. It makes a method call like change contact telephone number. Okay? It's a perfectly standard method call. Nothing tricky, right? It doesn't have to think about an async task. It doesn't have to think about any of that stuff. It makes a straightforward method call to do what it wants done. The service helper converts that method call into an intent. Now, there's a really straightforward way to do that, and I'll show you in a minute what that is. But an intent simply, if you look at an intent, you can see it as a method call. It's got a name, which is the operation that you want performed, and then a way to add parameters to it, and a way to get back a response, that's the trickiest part. But all this does, all the service helper does is convert from the method call into an intent. It's a very simple piece of code. It fires that intent off to this service. The service is there because it is the context in which everything beneath runs. That is to say, it is the context in which all of this stuff happens. The processor is the hard part. The processor does two things. It first marks the corresponding record in the content provider as dirty, and then fires off a request that will synchronize it up. One of the great things about this is that means that the dirty marker is in the content provider. You can reflect the complete state to your user. At any time, your list view for whatever's in this content provider, for instance, your contacts, can, for instance, show this guy in italic, saying, this guy is dirty. Okay? Your state is different than the network state. And that can persist for months. Right? You can show, because the dirtiness, because the state is in the content provider, you can reflect it to the user. Finally, the REST method is an analog of the service helper. The REST method simply translates a method call by the processor, which says, update the telephone number on the network, into a REST call that does that. Inbound processing works nearly the same way. So the network data changes state, and that can be a number of possibilities. Either the request that the processor sent out gets a response. I've updated that record. Or you get a GCM call, or worst of all, you have to poll. Now, if you don't control the server, you might have to poll. There are good ways to poll and bad ways to poll. All ways to poll are better than getting push, but sometimes you have to do it. So the REST method calls the processor with the state change. The processor updates the content provider. And if that caused a real change, your app finds out about it. The UI finds out about it because it has registered a content observer. Is that pretty clear? So one of the things that Mr. Dobjanschi says in his presentation is that he's not going to show you code, and he hopes you're glad about that. So I'm going to show you code, and I hope you're glad about that. So the case for this architecture, it's dramatically simple. Dramatically simpler. I've spent maybe a year working on developing, researching async tasks and how to make them work and what to do with them. And they get bizarrely complex. They can get bizarrely complex. And not only that, but stuff that applies to all of your async tasks gets distributed across each of them. Okay? It's hard to build async task frameworks. It's hard to build a framework that underlies your async task. Okay? It's hard to abstract things out of your async tasks. You end up with these tremendously complex async tasks that do such things as retries, right? It's just horrible. Or when they fail, they try to post a toast or put something in the status bar or something like that, right? It's awful. This architecture almost gets rid of async tasks. It basically gets rid of async tasks. They're hidden in an intent service. Yeah?
So if it is not a cursor, suppose it's not always cursor, right? Sometimes I may not have cursor.
Yes.
So how do I refresh my UI without async task?
So you need to register a content observer. It's very easy. Registering a content observer on a cursor is really simple. And not only that, if you do so, what I'm saying is it just makes it easier. Okay? Loaders know how to handle cursors. Cursors know how to handle content observers. Okay? If you aren't going to use that really easy path, all you have to do is read up on content observers and be one. All you have to do is handle the change. So the downsides of this architecture is that the content provider can be complex and the processor is complex. Okay? It's tricky. So as I said, just dumping async tasks is a major win. The async tasks now live in the intent service. Okay, this is a very good thing. Who can tell me, who knows the two big problems with async tasks? What are the two big problems with async tasks? The first one is leaking them. The first one is that if you have a pointer to an activity from your async task, then the activity can't be garbage collected for the life cycle of the async task. Okay? That means that anytime that this async task has a different life cycle than your activity, if the async task has a reference to the activity has been leaked. Okay? You've leaked an activity. Activities are big, ugly objects. You don't want to leak them. The second, yeah?
That should be handled by proper on-destroy method.
By
proper on-destroy or on-stop methods for that too.
Exactly. That's exactly correct. On the other hand, if you destroy an async task that is in the middle of handling a retry, you've got a problem. The second problem with this is that when it fails, it may have nobody to talk to. At worst, it will still have a reference to this activity which has been destroyed, and it will try to use it and it will crash. At best, it won't have a reference to anything at all, and the failure just goes away.
Yeah, but that's not the fault of the async task itself. It's just incorrect implementation, bug implementation.
My claim is that it's really hard to implement async tasks correctly. Okay, so in particular, one of the things that you can do, and I actually have code up on GitHub that'll do this, is you can drop the reference to this activity and pick up the reference to this one. That's a perfectly legit thing to do. But it makes your async task this incredibly stateful thing. You can do that. You know, Godspeed if you do. What I'm suggesting is that there are simpler ways that this architecture puts that complexity in one spot, and it makes it really clear how it works.
Why would you do a combination? You're combining the async task
Yes.
just as a way to update UI.
Update. Yes. That's a great idea. Yes. It's not what I'm doing here, but that's a great idea.
In this case, your async task becomes really simple because all it does is send
Yes.
to the service and
And there is an async task here. There is an async task in this implementation, and I'll show you where it is in a minute. So, walking down the stack, the service helper, although one of the things that's kind of hard about Dobjanschi's talk is that he draws this architecture in which all the boxes are the same size. Okay? And the thing is that the service helper, the second piece down the stack, really is incredibly simple. It's an incredible, he is separating these things into their concerns. He is separating them architecturally. But just because he separates them architecturally doesn't mean there's a huge amount of code that comprises each one. Some of them are very simple. In particular, this one and this one are very simple. The REST method and the service helper. So let's walk through this service helper and see what it does. So there are a bunch of ways to implement this service helper. The service helper's responsibility is to hand this task. It gets a method call from the activity that says, for instance, update this contact's telephone number. And what it wants to do is it wants to pass that off to a service. Okay? There are a bunch of ways to do that. One is you could bind the service. So when the activity wakes up, it could bind the service. When it binds the service, it gets back an interface, and it uses that interface to make calls. Okay, that's perfectly legit. Another possibility, much less legit, is that it can use some kind of communication mechanism that involves broadcast intents. Okay, that's entirely possible, and it might be useful in a case where you want to do pub sub. Okay, where when the service replies or something like that, you want lots of pieces of your UI to update, right? It would make sense to do a broadcast there. The one I'm going to show you is the one that is newest to me, and the one that I think is sort of simplest and easiest to grasp, is doing it with a pending intent. This is kind of cool. So here's the code. I hope you can see it. So this is the method in the service helper. Okay. So the activity calls this service helper. The service helper is a singleton that the activity knows how to find. It calls send my request with a bunch of arguments and the current context and itself. All right. So all that this guy does is build an intent. This part is pretty much straightforward. The only tricky part here is this thing, this create pending result. Create pending result is a method on activity that creates a pending intent, which, when it is sent, will call the activities on handle something. On activity result. Okay, so this method creates a pending intent. It creates a little object which, when its send method is called, will, first of all, even if it is in a different process, let alone a different thread, from a different process, it will change to this activity's, that intent will be fired from this activity's process, and it will call its on activity result method. Okay? So what we're going to do is we're going to pass this intent as one of the arguments. We're going to send it off to the service. Here's the service. So we're walking down the stack. That's the service helper. The service helper calls the service. Here's the service. This, by the way, is where the async task is hidden. A normal service doesn't have an onHandle intent method. It's got an onStart method. The onStart method of an intent service essentially spawns a new async task and hands it the intent. That async task calls onHandle intent with the intent. So this method runs on a background thread. Okay? You've gotten this thing. So it is a common misunderstanding, probably not in this room, that services run on a different thread. Services, in fact, run on the UI thread. In general, a service runs on the UI thread. In order to get things off the UI thread, you can use this intent service, which gets things run exactly the way you want them. It gets them run in order and on a thread, in a thread pool. So this guy, process request, is the local method that does whatever it needs to do. Okay, this is the brains of this operation. It's, you know, it's an implementation. It's your business logic. But it is passed all of the arguments. This guy put all those arguments in here, added them as extras with their names. This guy now gets them out and uses process to process them. Whatever this thing returns is put into the response with the tag return. And then we just send that, we pride the callback out here, right? So we put the this pending intent in with the name callback. Here, we get it back out. So this thing is the pending intent. And now we just send the pending intent. This response is this intent with these extras, with this return value put into it. So now we have an intent with the return value in it. This does an intent fill-in. That is, it copies all the stuff from this into the response, the pending intent response, and this sends it off. And now we're back at the service helper. So this is the return to this into the service helper. The service helper's onActivityResult method is called as a result of this send causes this method to be called. Inside that method, we use the service helper. We just invoke the service helper's handle response method. It gets the result status and pulls the return value out. Actually, this probably should be get parcelable. This is really neat. It's sweet and simple. Okay, there's no binding services. There's no worrying about broadcast intents flying all over the place. Okay, it's really straightforward. It's really simple, and it's frameworkable, and it's on GitHub. So moving down the stack, the processor is the part of this that's hard. Okay, the processor is the thing that has to handle what happens if there are multiple requests outstanding at the same time, and so on. It has to handle all of that stuff. I assert, though, that it's practically impossible to handle that stuff with an async task. If you have an async task and the guy hits the button, the guy mashes the button, and you launch a bunch of these async tasks, I mean, I found that hard to take care of. I found that to be a real pain. It's real easy to handle. The processor knows. The processor simply records whether there's a pending request out to sync this data or not. And if there is, it doesn't do anything. If there isn't, it marks it dirty and starts one. You do have to manage concurrency. There's all sorts of concurrent stuff happening. There's stuff coming in from the top that's concurrent. There's stuff coming in from the bottom that's concurrent. Use transactions liberally. Watch your database. The database, it is possible to corrupt a SQLite database with concurrent transactions. be careful. And finally, there's the REST method. It's not always appropriate, but if you're actually going to do this stuff, once again, I recommend have a look at using a sync adapter. A sync adapter isn't always the answer, but it's often the answer, especially if you have to log in. Okay? Especially if synchronizing implies logging in first and then synchronizing. A sync adapter might be just the right thing. And finally, this note. This is hard to find. For instance, when I had to find it for this lecture, I knew it existed, but it's hard to dig up. It is in the documentation for default HTTP client. It says that if you're using old Android, use the Apache client. But despite everything you hear, everything that you hear to the contrary, post Gingerbread, use the HTTP URL connection.
Where did you see that?
Yeah, it's in the docs for default HTTP client on d.android.com. Dobjanschi, for instance, says exactly the opposite, but that's because he's on Froyo. So, the point here is that in the long run, async tasks are flawed in that they hide state transition in objects that are ephemeral. Okay? They wrap the entire state transition in something that is going to go away. A better idea is to put the state transition where it belongs. Put it in something persistent. Put it in the database. And finally, let's talk about embracing content providers. I have a harder time making this. Let's see. I will argue the preceding two things. I will argue about with you. I will stand my ground on those. This one, not so much. This one, I can imagine that just taste dictates that you want to do it differently. My belief after I started out, let's see. One of the first things that I saw was documentation in the description of content providers that says when you're designing a content provider, the first thing you need to think is, as it says here, first thing you need to consider is that if you're not going to share your data, you may not need a content provider at all. So I wrote 7, 10 applications, each one of which had its little DAO that hung in the application. Okay, just take the DAO, hang it in the application. Anybody who wants it can get it from there. Okay, it's a singleton. I end up thinking that's the wrong thing to do. I end up thinking that in Android, a content provider is the DAO. Just use it. My reasoning, all of the arguments for cursor apply. All of the things that I said about cursor apply. In particular, if you look at a cursor loader, it works. If you look at an async loader, you will find that it doesn't. Okay, there's been a bug outstanding since version 8. Well, no, obviously not. Since Honeycomb, so since version 11. There's been a bug that requires you to write a little Boolean two-step to make sure that your cursor loads. Okay, that's not in Cursor Loader. Cursor Loader just works. If you write your own subclasses of async task loader, you have to. They don't necessarily work. You're going to have to track down that bug and make sure you fix them, right? And the last thing is that a content provider allows you to publish your data to other tasks, to other things. And my suggestion is that in the long run, that's the Android way, right? The Android way is make your stuff public, is let other people use it. Let other people use it in ways you didn't expect, right? I think you're going to want to do that. So do it now. The problem is that the API is constrained. It's a REST API. It means you have to get used to the idea that your activities are going to do REST. The back end of your activity is going to be RESTful. Okay? The thing that I find most annoying about it is that batch operations are harder. Batch operations are tricky. Trying to do a lot of things in one transaction is kind of a pain. And as I said, I admit that this case, it's harder to make this case than it is to make the previous two. On the other hand, it's a chance for me to talk about the query builder, which is really cool. So if you build a content provider, your contract publishes the names of virtual tables with virtual columns in them. Don't make those the real columns. Don't make them the real tables. It's exposing too much information. Obviously, if you do that, people will depend on it, and when you change your database structure, they'll break. Okay? Make sure that they can't ever see the real tables. Make sure that they can't ever see the real column names. And the query builder is exactly how to do that. So first of all, when the content provider gets a request, it's going to get the request through a URI. That URI determines the name of the virtual table. So you can use any table you want. In fact, what you will commonly do, or what you may very well do, is build a virtual table out of, for instance, a join of multiple tables. Okay? So you will build a virtual table in response to this query, and you can pick any table name you want. It's not specified in the query. All you get is the URL. On the other hand, the projection is part of the query API. So your clients are going to tell you what columns they want to see. And it's tricky to make that work. The query builder supports something called a projection map. And the projection map, so if the way you come on a query builder is because you want to build complex SQL queries, it appears to be the only way in Android to build, for instance, a join query. Okay? But if that's the way you come on it, you're going to see this projection map and you're going to wonder, what the heck is that thing for? And my guess is that the projection that Query Builder was originally written to support content providers. That's why the projection map is in there. And it happens to do some other things as well, right? It happens to do joins as well. But it was written to support the content provider. So the projection map is simply a map of virtual column names to the names that you actually want to use. A naive mapping won't work, okay? And this query is an example of why. So if you naively map your virtual column name to the actual column name, right? So your projection map simply contains the virtual column name as the key and the real column name as the value. What happens is that, for instance, it will end up mapping ID. It will say select real column name because it will replace the virtual column name with the real column name from my table, order by virtual column. Okay? So this is nothing anyone knows anything about. Okay? That query will fail. Do you see why this query will fail? I didn't make it clear here. But what you've done is you've replaced virtual column in the projection with real column, which is the name of the real column in the table. But you didn't do it out here. You didn't do it anywhere else in this query. So if it's in the where clause, it won't work. If it's in the order by clause, it won't work. On the other hand, there is something you can do, which is in your projection map the virtual column name to real column as virtual column, to the string real column as virtual column. Okay? And this works great. So, for instance, all SQLite databases have a virtual column called row ID, which turns out to be an integer primary key. In order to see something in a list view, you need an integer primary key called _ID. Well, what if your table doesn't have one? Well, it does now. So you just map row ID as ID. And real column as virtual column. Now this virtual column works.
Could that be seen as a bug in the query builder that doesn't use the projection map for where and order by clauses? I haven't had too much exposure to it, so I'm not sure.
I think that this works pretty well, and that means they're going to have to parse everything. And not only that, but SQLite is going to parse it again. It seems like this is sort of the best way to do it. So this is what you get. This is the virtual name. This is the virtual name, and you map it to the virtual name, or the real name as the virtual name. And one of the things that you can do here that's pretty cool is this is a completely virtual column. This is completely made up, right? But I have this case that I then map as the virtual column name. This is important. I didn't mention this, but this is important. If you are normally, the query builder will throw an exception if there is no key matching the name of a column, unless the key contains the word as. So if the projection says select foo as bar, that will pass through. But if it just says foo and you don't have any column named foo, you'll get an exception.
What about the column named bar?
No, it's the key. It looks for the key. So it looks at these things and matches them as keys in that table, right? So if it can't find this as a key in your table, it's going to throw it out unless it looks like this. In strict mode, it doesn't care, even if it has an as in it. This makes you very safe. This means that even people who guess your implementation can't get through your query builder, right? They can't pass the real names of your columns through. And the query gets dead simple. The query gets just completely trivial. Set strict. This, by the way, this method appears in maybe 13, so it's not available in older versions of the API. Set the projection map. Set the table. Run the query. It's safe and easy. As I say, I have a harder time making this argument. I admit that I even sort of sidestepped it. I haven't really made a strong argument for using content providers. I think it's the right thing to do, though. I think the strongest argument for me was the cursor loader. So what do I want you to take away from this? So at a high level, when you're working with people, so you will, when you're building enterprise applications, it's half yours. If you're working in Android, it's going to be half yours and half somebody else's. Okay? And not only that, but you're going to get into each other's spaces and you're going to start talking about each other's designs. Be prepared to stand your ground. Be prepared to know what you're talking about and convince other people to try a new way. Okay? There are things on mobile platforms that, honest to God, don't look like look like servers. Be prepared to make that case. On the other hand, also be prepared to try something new yourself. Android is not standard mobile. Android works differently. The similarities between Android and J2EE are astounding, right? All the way from life cycles to the difficulty to debug. difficulty to test and debug. There are things that people who have done back-end development for years will know about. If you come from strictly mobile space, be prepared to learn from them. Don't fear the cursor, just go ahead and use it, right? Go ahead, use cursors all over the place, invent nice ways to wrap them up, but go ahead and use them. And only use async tasks locally. Don't ever try and do something over the network with an async task. It's possible, but it's just a bad idea. And then, some other things that I hope you take away from this, or at least have access to the code to do. I proposed a way to wrap a cursor that I think is pretty clever and pretty useful. I use it a lot. Using a pending intent for a service callback is very simple. It doesn't require binding. It doesn't require AIDL. It's very simple, very easy to implement. I recommend it to your attention. And finally, using the query builder for mapping to map virtual tables to real tables inside your content provider. Thanks a lot. Slides and code soon at GitHub, bmike, and it will probably be I haven't put it there yet, so I can't be sure of this, but it will probably be in AnDevCon 4. If it's not, it'll be nearby. All right? Thanks a lot.